we're going to rely heavily on a graphing calculator to take the concepts we know and to shorten the process of solving here, knowing we get to use a graphing calculator. So up to this point, when we worked with rational functions, we could generally factor and then make it a lot easier. Like an example really quick, we could factor, this is not true for this one, but let's say we had a question, q of x equals x minus 3 and x plus 2. On the bottom we had x plus 5 and we had x minus 7. And what would this tell us? Okay, this would tell us, all right, we got an x-intercept at 3 and an x-intercept at negative 2. We have a vertical asymptote at x equals negative 5 and x equals positive 7, right? And when I factor these, by the way, I also noticed that x squared is on top, x squared is on the bottom. Oh, we got the same degree on both. That means that we are able to take the leading coefficients and we can divide to get a horizontal asymptote of y equals 1. That's what we worked with leading up to this. Now, again, we can see we have a horizontal asymptote, right? We have a horizontal asymptote of y equals 1. Why? Because we have the exact same degree, so then we divide the values in front. So I'm going to write down horizontal asymptote of y equals 1. But here's the problem. We can't factor this. It doesn't mean we can't solve it. And we can't factor this in order to solve. So then we have to rely on the quadratic formula, or here's a shortcut. So grab your calculator, do second plus 7, 1, 2. And if I solve the top, you could use quadratic formula if that makes you feel better, but we're under time constraints. I'd use a calculator. If we solve this on a graphing calculator, that means what are the x-intercepts when you solve? So let's do that right now. Solving the numerator finds the x-intercepts. So I'm going to come up here and I'm going to type in x squared plus 7x plus 4, and I'm going to solve. Okay, so second trace, go to 0. This looks, okay, we're going out by ones here. This looks like this is between left bound, let's say negative 9, and let's say negative 5. It's somewhere in between there, and I press enter. So one x-intercept is at negative 6.372. Let's find this next one. Second trace 0. This looks like to the left, it's between negative 5 and 0. Pressing enter. The other one is at negative 0.62628, it rounds to. Those are the x-intercepts. Now let's go now and write x equals and x equals. Those are the x-intercepts. Now let's find the vertical asymptotes in the same way. Remember, I would solve these and whatever I got would represent the vertical asymptotes. So I'm going to do the exact same thing. I'm going to grab this and I'm going to type in x squared minus 2x minus 6, and I'm going to solve. Now what does it mean to solve when we graph it? We're just, again, let's find out where does it cross the x-axis. So second trace is 0, starting to the left, somewhere between negative 5 and 0, pressing enter. That means we have a vertical asymptote at x equals negative 1.645. Let's do the next one. Second trace is 0. It looks like it's between positive 2 and positive 8, somewhere in between there, and we have 3.645. X equals 3.645. Now what do we know about this? So these are vertical asymptotes. That means the graph will have no output value on vertical asymptotes. Keep that in mind. I'm already looking up here and I can see this. We're asked, where is the y's? Remember, r of x is like y's. Where are the y's? We want to know where a y is greater than or equal to 0. Okay, so then I'm going to graph this. So I'm going to come back here and I'm going to put a parenthesis, and I have x squared plus 7x plus 4 divided by x squared minus 2x minus 6. And let's end parentheses and graph it. Now, if I was able to draw on here, I can see that we would have a horizontal asymptote of y equals 1, which I already determined. There's my y equals 1. I have x-intercepts at negative 6.3, and I can show you that. Here's a value. Let's go negative 6.372, and we can see that's pretty much there, right? That's our x-intercepts. We also have another x-intercept here. And then here are my vertical asymptotes right here at negative 1.645 and also at 3.645. -645. And so it doesn't say it's going to list it does not say it's going to list all of the intervals. It says for which of the following intervals. So which one of these, we're only listing one in which the y values are greater than 0. So if this is an x-intercept, I know way over here is greater than 0. So one interval would be like from -infinity all the way to this x-intercept of -6.372. It can't touch there, right? It can't touch, sorry, it can include that. It can include that. Let me go back. It can include it because the y values are greater than or equal to 0. So at the x-intercept, y is equal to 0. So let's see if that's up here. Okay, that's not an option. So if I zoomed in, we can see this is slowly getting bigger and bigger. It's above the x-axis. Let's go to this next range. This next range would be, so this portion right here. Okay, think of this having the boundary line here of your vertical asymptote. Here's your vertical asymptote we're talking about. So 1.645, why am I making a parenthesis? Because the function actually never touches this x value, and it goes all the way down to this x-intercept right here of -0.628, and it includes it because at that point y is greater than or equal to 0. Let's see if that's up there. Is that an option? Sorry, this is what I'm talking about, and let's see if that's an option. That is an option. It is option B. That is an option. There's only ever going to be one correct answer. We can already move on. But for those that are like, what about this? What about this? Let's just talk about that quickly. So on this particular graph, we have this horizontal asymptote right here of 3.645. But keep in mind, it is, I said horizontal, I meant to say vertical. This vertical asymptote, the function will never actually touch at that point, right? There's not an actual output value. But we can see then as it moves to the right, it continues to be positive. There is going to be that horizontal asymptote of y equals 1, so it will remain positive. But we can't have a bracket here because that is the value for the vertical asymptote. And that is up there, but notice how it has a bracket instead of a parenthesis. That's why we're able to eliminate that choice. The correct answer is B.